And I'm going to be talking about some relatively unholy things here. So, so how to integrate like Scala and like Java with your Python code. So a little bit about me. I'm Marius. GitHub that, Twitter that, because those are double underscores because Python, right? So I'm a software engineer / data scientist at MaxPoint. And so why would you want to do this, right? So, we do things where we integrate sort of C and like Python all the time. But why would you want to do Python and Java? It's like the JVM is like its own magic world, and it's kind of hard. And the main reason is like you're working at a big company or a really big company, and you have millions of lines of Java that people have written over decades. And so you want to use that stuff because some of it is probably pretty good. I mean, some of it maybe isn't, but you still want to be able to integrate that stuff without having to rewrite it in C or Python to go and make use of it. And the JVM is relatively fast. It's not as good as C, but you can get some pretty decent performance from it. And there are some nice sort of high-level languages that exist on top of the JVM that give you a lot of things. So how would you do this? So the first way you can do this is you can do this via sort of some remote procedure call system. So this sort of the thing that's touted as this sort of the service-oriented architecture, where you have some Python process and it talks to some Java process over a protocol. So Apache thrift, REST, protocol buffers, there's many. And this obviously adds some complexity because now you have to have an entire system dedicated to managing that sort of communication protocol stack. And you need to go build tools, put tools around that. So that's kind of heavyweight, but ultimately it's probably not a bad idea. You can use Jython, but you shouldn't use Jython because Jython is not a real thing. It's like, I mean, you can get it, but it's like, great, now I have something that sort of like vaguely looks like Python, but I can't import NumPy ever. So that's a non-starter. Or you can use Py4j, which sort of, there are some people that don't like Py4j, but it does sort of what it does relatively well. When things break, you will have fun times because now you have like fun Java stack traces inside your Python. But once it's sort of like working okay, you're pretty good to go. And so Py4j, it's a remote procedure call system as well. So it still, doesn't try to do something crazy like embed Java inside the Python process space, because that's really hard, and there are people that have tried that, and that always fails. So it works quite great for like standard Java code things, but a little bit more coercing is required for making it work nicely with Scala. And you can probably do Clojure with it as well. I haven't bothered or tried. So a simple example of how you would do this is if you have Py4j installed and you have a JVM installed, and those things are required, obviously. So you can basically import a Java gateway. You can start a Java gateway. There's a whole bunch of additional parameters that you can pass there of setting up how your Java class path works and things like that. That's an exercise to the reader. And you can get sort of a JVM handle, and I can actually just call like java.util.random, which is a Java class that gives me a random number generator, and I can call functions on this. This is all pure Python. So what exactly is going on here? So when you do this, it launches a sub-process, and your Python process will talk to that thing over a localhost socket. And it uses a weird, magic communication mechanism that's like specific to Py4j only. That's sort of some of the annoying parts of it. And when you call java.util.random, that sends a message over that socket instructing your Java process that sits on the other side there, please go make me an instance of this sort of via Java reflection. And sort of hold a reference to that thing around and return like basically just an integer back to the Python process saying, by the way, I made you this object. It is object number 5. And your Python process can then use that to talk back to it. And then when you call a method on that, the same thing happens, where you send sort of, the Python process sends sort of an integer saying on object number 4, call the method called nextInt with these sort of argument types. So it'll sort of serialize all of your arguments into something that Java can understand. So all primitives are done, and then lists and dicts automatically get converted as well into sort of standard Java-like types. And I'll try and find a method via things, call it, and sort of do the same proxy sort of object magic that is required for Python to sort of know about your result. If it can be converted back into a Python primitive, it'll go do that as well. So if you have a function that, say, returns an int, then Java ints will get converted to Python ints and vice versa. So working with primitives, is relatively simple. And if you're doing Py4j stuff, that's you probably want to stay there, just because when you start dealing with lots of Java objects, it can become a little complicated to know really what's going on, because your code still looks like Python at that point, but it really isn't. So using this, we can use all of Python. There are no constraints on which libraries you can use. So as much NumPy, sort of NumPy C extension runtimes as you want, and you can use every Java library. So that's kind of nice. So and there's like a lot of cool things you can do with this. And so the largest sort of standard user of Py4j that's sort of popular now is Apache Spark. So Apache Spark, it's a distributed computation engine, sort of written in Scala, and it has some Python bindings called PySpark, so that you can write your big data distributed processing thing inside Python, because data scientists don't really like writing lots of Java and Scala, so we'll try to avoid it. So they were kind enough to provide us with Python bindings, and all that the Python bindings really are is it's basically just calling out to making a Java subprocess and using Py4j and talking with it. And sort of dealing with Python types, it does with some pickling and a fair bit of sort of magic using, there's a library called Cloud Pickle that it uses for sort of serializing things like closures, which Pickle doesn't serialize closures. And maybe at some point they'll switch to Dill, who knows. But so what goes on when Spark does this stuff? So you make a Python process, and this Python process sort of says, okay, well, I need to go talk to Apache Spark. It'll make you a child Java process, and it'll go and spin up some kind of other Java process, possibly on a different machine, probably on a different machine, and it'll talk to it via sort of a standard out thing. And the Python process actually talks back to the Java process via socket. So it's this crazy sort of interconnected layer cake of pieces. And that's all kind of terrifying. But luckily, you probably don't need to care about the internals of how that works, except when it breaks. Because now you have a Python stack trace inside a Java stack trace on a remote machine that maybe you log, you hope. But it's it's okay. So PySpark is using this sort of Py4j thing, and we can just use this. We don't actually have to use Spark or rely on the internals. We can provide our own things to it. The only thing that's sort of annoying from the Py4j side is Scala, right? So Scala is, in many ways, basically just a better Java, because Java programmers like writing lots of lines of code. I assume they get paid by the character. Scala programmers are seemingly the opposite. They hate writing characters. So your code is nice and terse, and it has lots of sort of nice functional things, and it's easy to do sort of highly expressive code, much like it is in Python. The sort of machine learning libraries aren't quite there yet, which is why you'd want to sort of work inside Python mostly for doing your data science work, and then sort of Scala maybe for doing production sort of production data pipelining. And sort of you can get by with this, and it works fairly okay. So in order to deal with the annoyances that is Scala, I wrote a little library called spylon. It's a sort of point menu of Scala, Python, and it makes it easier to interact with Scala code from pure Python. So it provides a bunch of conversions for simple types, and some import helpers for dealing with sort of Scala constructs. So Scala is a thing called an object, which is similar but not quite the same as a Java static class. So you'll need ways to get those things because you're probably wanting to use them if you're writing sort of Scala code and you want to use that from inside Spark and Python. And because Spark is a very big user of Scala, a whole bunch of like helpers is also part of this for sort of making it easier to work with Apache Spark. So if any of you have tried to use like Apache Spark from within an IPython notebook, it's relatively painful to get like all the configuration correct because there's parts of the configuration that you need to set that are magic environment variables that are relatively poorly documented. And we'll just do that for you so that you don't have to care that much anymore. And it also has sort of some extensions that deal with running applications on Mesos and Yarn in custom Anaconda, custom Conda environments, so that you can just sort of say, well, I need to run NumPy version 1.11 on my cluster. I'm not going to go install it by hand everywhere because that's really hard. So let me just have some mechanism that I can provision that entire environment over my entire cluster at runtime and build that thing sort of on the fly as I submit this. And that's sort of mostly adapted from some blog posts by the guys at Continuum, and it allows you to sort of get up and going pretty quickly and easily. So let's go into what this stuff actually looks like in real life. So because I'm not that brave, I'm not going to do live code demos. Sorry, it's hard for me to see from this angle. Okay, so cool. There we go. So spylon is heavily sort of inspired by Apache Spark, but you don't actually have to use Spark to use it. For sake of the demos and making it easier to just have a JVM around that has the necessary Scala libraries to do this stuff, I will be demonstrating it using sort of Spark as the Java side of this, but it's not required. If you want to use the Scala pieces, obviously you need a JVM that has the necessary Scala libraries around. So top bits are just sort of boilerplate. JVM helpers is sort of the pieces that allows us to sort of interact nicely, cleaner with the JVM. So some simple calls. So we're going to make, that same demo. I made a random thing here, and I'm going to print out what that looks like. That looks like that. That's not super handy because that just says rand. What's that? It's like, what can I do with this? And Py4j is sort of sufficiently good that, it'll actually print out, you can still get documentation on like exactly which methods exist, what types to call them with, sort of so that you can know what's going on and have like full introspection. Obviously you don't get things like, you can't get things like doc strings because Java is kind enough to compile them away because they're just comments. So that's sort of annoying. But you can still get a lot of details on like, I have this rand object, it has these methods, I can go call them and it all works. So for example, I can call rand.nextInt and I get a number, I can call it again, and this is all running on a JVM that's a subprocess of this thing. And then sort of some simple conversions, because at some point Scala has a couple of sort of key collection types that are not the Java collection types. So it has a thing called a seek, which is analogous to a list. So when you get one of these, I can convert standard Python list into a seek, and I get this thing. It's once again a Java object, nice and opaque. But you can call methods on it that's saying like, what is this thing really? Now, like the actual class name for these things looks terrifying and horrible. That's just sort of mostly an implementation detail of how Scala works. And generally, you shouldn't need to care. But if you want to, you can just go look at what's actually going on. And you can still get like a nice representation of it. It's like, that looks like a list. So you can still get some sort of, you can get it in sort of standard things that sort of make sense to you. And the same with, I can do dictionaries and, get these sort of structures that exists on, so that I can easily sort of jump to the Scala side of argument types when I need them. You can also just call standard Java constructors, which is what we did up here. Is java.util.random is just a class name, and it happens to be that this class has a constructor that takes 0 arguments. So, you can still do all that stuff, and it still doesn't look that foreign to Python users. I mean, that's a pretty long string of things there, but that's sort of okay. So what if we don't want to do, something cooler, right? I mean, converting things is all fine and well, but what if I actually want to, what if I want to, actually write some code? So let's do that. So I'm just going to make a directory. I'm going to call it hello Scala. That already exists, but that's because I ran this demo before. And I'm going to just inside the notebook, just make myself a simple Scala file. And this is just standard Scala code. It looks a little weird, but there's not that much to this. I'm basically making a singleton called hello Scala. It has 2 methods. It has a method called say hi that returns a string, and the string is just hi. And it has a method that sums 2 integers. So not a particularly complicated example. So we'll go print that, and we can just go compile this. So I'm compiling, so I'm just running SBT, which is sort of Scala's compilation tool. But you can use whatever you want. And that's going to spit out to me, a jar file. So In the same way previously, where we sort of imported this sort of spylon and sort of started a fake Spark thing that we weren't using for Spark just because it happens to have an interpreter around. We can also just add jars that we need. It's like, please add this to the Java process when it starts up so that we can import our class that we just defined up there. So starting this stuff up will take a little while. And let's go and import the helpers again. And we'll just go import our Scala object that we've defined. It's called hi. It has a doc string, just like we saw previously. And we can go call methods on this. So, in like very, very little amounts of code, we wrote like some JVM code, sort of compiled it with Scala, and just called it with very, very little effort from a Python process. And that's kind of cool. And you can clearly see that if you have more complicated systems that you want to interact with, the same process applies. There's nothing particularly weird or magical about this. And just to prove we can actually pass arguments, because you can just call methods and it works. And this is all fairly standard. So the main reason why we probably want to do some of these things is particularly with respect to Apache Spark, is defining things like if you have sort of user-defined transformations that you want to run inside the JVM space. Keeping those things inside Java land is much more efficient from sort of a runtime behavior. So sorry, I'm going to jump back a bit. So, really? Fine. So in this process, if you're running this distributed code, at that point where your Java process is talking to the Python process, there's a serialization thing that's happening there. That's not free. And when that Python process talks back to the Java process, there's another serialization that happens there, which is also not free. And then, when this running program talks to that Java program, there's some more serialization. So you have all of these sort of serialization gates there that you pay a toll for every time you use them. And that toll can be expensive. So, in as much as possible, what you'd like to have is you'd like to set up a system so that your Python logic, which sort of dictates the flow of how this thing is going to operate, that can all be inside Python. And when you encounter a bottleneck that something is slow, you can take that tiny little piece there, and you don't need to go rewrite everything, which is the standard behavior that people seem to like doing. It's like, just keep your Python code. It's fine. There's just one slow piece, and you can just rewrite that little bit inside Scala. And using Py4j, you can just link all of this stuff up as if you wrote the entire thing in it, but it's like, oh, I'm just going to call out to my sort of transformation function that knows how to do this. And that's sort of a powerful abstraction that gives you a lot more sort of flexibility in how you structure sort of efficient code. If your data is not particularly big, you can do whatever you want. It doesn't matter at that point. It's like it's just sort of when you serialize and deserialize large amounts of things all the time, it adds up. And it can add up to sort of 10x performance penalties, which is undesirable, to say the least. So, oh, right. Great. What's it? Oh. So just because this is still, a lot of it is Spark-based, I'm going to just show off one or two kind of neat little features of this inside actual and running actual Spark. So Spark is like a billion ways of doing configuration. And in order to get it correctly working, there's like 200 parameters or so that you need to tune because, big data. So that's fun. What are they? Well, they're all like vaguely undocumented. That's also fun. So you need to know these magic strings. On the bright side, at least we can, on Python, do some things where, oh, I can now find that I have some setting called spark.executor dot, logs, whatever. And I can go see what that means. And you can basically get sort of a description of like what all of these settings mean, what their behavior is. In fact, this looks like I had like a nested setting. So what did the rolling logs look like? And all of these are it's just lots of configuration. But you can get sort of details and you can configure all of these and set sort of behavior of how they work. And that's sort of nice for having sort of more Pythonic things rather than giant dictionaries of these big ugly keys that you carry around all the time. So I'm going to do the same boilerplate again. So who here has actually used Apache Spark within a notebook? How many of you love the fact that you don't have progress bars? Because you're going to run a job. It's going to take an hour, maybe. Who knows? And you get the progress bars when you were running in like the Scala shell. So why can't we have those? And the answer is, well, we totally can. So this is just a simple example. I'm going to run a little thing that basically sleeps and does nothing. So I'm going to run that now. And this is the standard thing that happens when you have a Spark job that runs, right? So you'll star there, and you kind of watch to see if that star changes. And it's not changed yet. So, who knows what's going on? I mean, you can go look in the logs of your Jupyter terminal, and you realize there's lots of stuff going on here. But you have to go look at that. So, it's finished now, but I would have liked to know, when's that going to be on? So let's turn on some progress bars. So, we can actually do things and it'll tell you what's going on. It's like, that's sort of, and none of these things are particularly complicated to go implement. It's just, PySpark is sort of to a degree, well, it is a second-class part of the Spark ecosystem because, it's all written in Scala and there is this piece, but, we can easily do things where we as the community can sort of provide additional tooling to make lives better for us all. And that's sort of, a lot of what I'm just trying to do here is, we're all writing these sort of internal things that make it sort of better for sort of us individually at our companies. But I think we can get together and sort of formulate a plan of like how can we move the Python side of this stuff forward faster. And so I'm gonna have to run through the whole deck again, hey. So how do you get this stuff? It's on GitHub. It's kind of installable. It's pretty easy. And we are welcoming sort of new contributors to the project. If you want to help out and do some of this sort of like unholy fusion madness, there's a lot of interesting things that that we have in the pipeline. So some of the things that I've been thinking about is we saw how relatively simple it was to just run or just like compile some Scala code on the fly and just inject it. We can just make standard Python functions that allow you to do this, and maybe even do completely crazy things, like do Python AST transformations and go and just make you write Python that isn't really Python. So these are all sort of things that can be done. Whether they should be done is a completely different question. But it's sort of, there's a lot of interesting pieces that sort of exists in this sort of strange intersection space between sort of big enterprise sort of software and sort of hacky data science. And I think it's a pretty exciting space to be. So with that, I'm going to open the floor for some questions. Hold on. Let Eric do his job.
Testing. Does spylon provide for the dynamic compilation? You did it manually.
Yes.
Does spylon give you the ability to generate that code and do the compilation programmatically?
Not yet. It's something. So the project's still quite young. Sort of we started it about 2 months ago. Sort of there was a sort of so I've recently been doing a lot of work on Apache Tori, which is a Scala Jupyter kernel. So the actual mechanics of how you would go about sort of doing this, I know how they work. It's just mostly a question of like putting in the time and getting some pieces going. Right now, spylon is a pure Python library. In order to get that stuff to work, we'll probably need to include some actual Java as part of this.
So thank you. We're going to have to cut this short because we got started a bit late. So let's thank our speaker. And
cool.